Hi, my name is Nguyen and today I will present a term project with a swimmer pole estimation with segmentation model, SAM and YOLOv8 model. So there are 10 sections in the presentation, but I only focus on some segment like data collection, swimmer segmentation with SAM, port detection with YOLOv8, maybe stroke classification, and we discuss the result and analysis. The motivation is try to hint by challenge like motion blur, occlusion, and lighting distortion in the underwater video. So when we use SAM and YOLOv8 model, we will improve the swimmer visibility and joint estimation. So at the end, we classify swim stroke with very high accuracy. This architecture overview is we'll go through 5 stages: modular pipeline, glue frame extraction, segmentation, SAM, port detection, YOLOv8, data structuring, and stroke classification. So during each step we'll face with specific challenge, and we will discuss during the presentation. Here's how we collecting data. We use the HASU swim team resources, and then we cut the video into small video by using the software like FFmpeg, and later we extract the small video into 100 frames. In my case, I use about 400 to 600 frames for each type of stroke. So the solution here, I use 640 x 480. It will enhance the processing speed as well as it fit for the YOLOv8 model. Here's the state of segmentation with SAM. So this will ensure the pole model focus only on relevant region, in this case the swimmer. And we will use like the Python to point from to annotate on the swimmer body, and then SAM will generate binary segment mark across all frames, isolating only the swimmer. Here is kind of implementation. We will perform across 4 stroke type: backstroke, breaststroke, butterfly, and freestyle. And this significantly improves visibility of control and reduce noise in downstream port estimation. So here the example is how we annotate point from on a swimmer image, and then how we generate from original and we get the output same image. This state of detection with YOLOv8 model. So we will detect 17 keypoints per frame, include like head, shoulder, elbow, hip, knee, and ankle. The input is from the same state, and the output will be the same image with overlay drawn and structure JSON file contain 2D coordinate and confidence score. There will be a strength and a quickness under water condition, but with the YOLOv8 will demonstrate the robustness against those challenges like body rotation, motion blur, and collision. And accuracy will detect what achieved over all 4 strokes. Here the visual reference after the detection step is the example cable overlay result on a segment swimmer frame across all 4 strokes. And here is how we implementation 17 Coco keypoint skeleton definition. Then we have like a small tab to structuring and labeling the image. We will save as a 4 JSON file for each the stroke type, and then we will convert all 4 JSON file into a CSV format. So, and for the CNN training model later, here the example of the JSON file and the CSV conversion. We will see how we name type of stroke and according to frame, and we have the join with the value with the data as well. So here the stroke classification state, we use a very simple custom one convolutional neural network built in Python, or only maybe one layer with partner value drawer, and finally fully connected layer for classification. Very simple. And this here is training setup with optimizer, large scheduler, and we have 4 classes: freestyle, backstroke, breaststroke, and butterfly. Here is the visual of architecture diagram and the CNN architecture code snippet for stroke classification. Here the result and some analysis. So joint estimation improve after segmentation with SAM. So it means I also do the port estimation with original image. So and the successful rate very low, kind of low. But with the SAM is we increase the successful rate. So for example, backstroke improve from 56.7 to 60%, where and breaststroke from 68.1 to 76.7. And there's some smaller for freestyle due to more dynamic motion and blur. It means like the qualify of the video is not really high qualify. So, and here the model accuracy. So we on the training side, both training and validation accuracy path 90% after 50 epoch, as seen in the plot. The large curve also cover closely, indicating minimal overfitting. And then look at confusion matrix. The butterfly and the backstroke were classified with high precision. Most misclassification occur between breaststroke and freestyle, like because of their overlapping leg and arm pattern in some frame. I will show you the example later. So overall, the model performed well from frame level prediction, but result also high limitation, like static frame sometimes miss the full motion context, especially important when stroke appear visually similar mid-action. Then we have some challenge and future work. The project face key challenge. Underwater condition control more motion blur, like mentioned before, lining visual obstruction like bubble, all of which impact joint detection accuracy. This limits its ability to capture full motion pattern, especially important stroke with overlapping limb movement. Future work we will explore temporal model to address its limitation. In summary, this project is a modular, effective pipeline for underwater swim stroke classification, combining SAM, segmentation, YOLOv8 for both detection and CNN for classification. At the end, accuracy very high and improved joint estimation tend to the same segmentation. So I will walk through the program here. So here is how we handle the same. We run on the CUDA. Here we point to the swimmer, and then it will generate here about 53 image. We will see the same segment around the swimmer, and then they handle about 53 image. Here we have from original image, because I run with the freestyle, so we have some original image, and we have the same with freestyle. Here you go, with very kind of high accuracy. Then we go to the post animation. Again, I do with the freestyle. Oh, basically, I think I got it. Should be freestyle training same first. Here we go. And then after the step number 2, we will get the same segment freestyle. There you go. And then we have the drawn, the session file. Then we go to the tab 3. I try to rename and try to export. We rename the image from some random name into specific type freestyle. And with the update the drawn coordinate, then we go to the step 4. We extract an CSV file, and then go to the step number 5 with the accuracy test. It stopped kind of early because it's we just have about 50 or 30 frames. The accuracy, we have the loss and the confusion margin. Overall, a very high accuracy. That's all for my presentation. Thank you for listening.